Alrighty, here we go. Chapter 11, Section 3. We're moving on to do some incredibly high-powered algebra. Very, very, very cool. So make sure you've got this heading up at the top that says Chapter 11, Section 3. We're going to be solving equations with variables on both sides. Okay? Variables on both sides. So your learning target today is basically going to be, I can solve equations with variables on both sides. Haha. So here we go. A number of examples that get progressively more difficult, and let's see how you do. All right, here's the first one. 7n minus 2 equals 5n plus 6. Now, normally, what I've always said to do is find the variable and get it alone. Problem is, this time I've got the variable on each side of the equation. So it's a little more complicated as to how we're going to get the variable by itself. So right now, you get to be kind of like warrior, okay? And what you're going to do is become algebra warrior, and you get to decide which one of these things you are going to annihilate. You can either choose the 7n or you can choose the 5n. Doesn't matter. You just pick one, and we're going to like blast it to smithereens. Okay? Sound fun? Ooh, yeah. This is like algebraic ninjas. Here we go. So what I do is I tend to look at these two, and because I don't like negative numbers, I mess them up. So I'm going to usually find the smaller one. I've got 7n and 5n, and I'm going to pick on the 5n, and that's the one I'm going to blast away. So the way to make this disappear is I have to lob some ammunition at it to make it wipe out. And so what you have to do is basically pick the opposite. If I have positive 5n, I am going to lob a negative 5n at it. And here's what happens. When I lob a negative 5n to this 5n, it goes to 0n, and 0 times n is just 0. So it goes away, and all that's left on this side of the equation is 6. Yes! However, when you lob things, you have to make sure that you lob it on this side to keep the equation balanced. You have to keep the integrity of the equal sign here. So when I lob my negative 5n on this side, and I say, all right, these two guys are like terms, now that gives me two n's. I still have to bring down minus 2. Now, I've changed the look of this equation, but I've made it simpler by simply performing a legal move, which is I can add or subtract or multiply or divide to both sides of the equation, and that keeps the equality intact. Now, sweet! This is a nice normal two-step equation, and I just say, here's my variable. I'm going to undo the subtraction of 2 by adding. There we go again. I get 2n equals 8. Hot diggity dog. Now I can simply divide so that I get my variable by itself. In other words, a coefficient of 1, because 1 times n is n. And I get n is 4. You should always go back, grab your calculator, check, put a 4 in here and see if it works. 7 times 4 minus 2. That's 28 minus 2. That's 26. On this side, I have 5 times 4 plus 6. That's 20 plus 6. That's 26. Looky there. Hot diggity dog, it worked. Okay, let's look at a few more. Write this one down. 5x plus 8 equals x. All right, first of all, I'm going to put a 1 there, so I remember what that means. Now, usually what I do is I say, well, I scan through that whole equation and I say, yep, I have a 5x and a 1x on this side. They're on different sides, so I'm going to have to annihilate or blast one of them to smithereens. I'm going to choose the small guy, the 1x. I do that by taking the opposite, negative 1x, and I'm going to lob that at each side of the equation. Watch what happens. Let's see, on this side, these two like terms combine to be a 4x, and I have a plus 8. On this side, this goes to 0. 0 x's, which is just 0. Now, don't panic. It's 0. 0 is a number. It happens to be smack dab in the middle of 1 and negative 1. It's a good number. Put 0 there. Now go ahead and solve. Okay. I have to subtract 8 from each side to undo this guy. Blasting that away. Let me get my screen extended so you can see around my big fat head. This is negative 8. Now divide by 4 so that I get my x variable by itself. That gives me a 1x, exactly what I wanted. And this gives me a negative 2. Sweet! Check it just to make sure. What's 5 times negative 2? And then add 8. That's negative 10 plus 8. I get negative 2. On the other side of the equation, it's negative 2. Hello! It works. It works. Now, you could approach this you could also have subtracted 5x from each side. In fact, if we had done that, let me just show you. I'm going to grab that same equation, 5x plus 8 equals x. You don't always have to pick on the small guy. I could have said, I'm going to annihilate 5x. Boom, chakalaka. And I lob this negative 5x on each side. Because then that is annihilated and all you have left is 8. On this side, I would get negative 4x. Oh, all right. Well, then I have to simply divide by the coefficient of x, negative 4, so that I end up with this to be a positive 1x, because that's my goal, is to get x by itself, and I get negative 2. See? It works the same. So you have choice now as to which one you want to blast away. I typically don't like negative numbers, so that's why I did it this way. Okay? Let's look at a couple more. Say I want you to make sure you watch out for parentheses and like terms. So we're going to add and get a little more complicated here as we go through and solve some more. And now that you're masters of the distributive property and combining like terms, here you go. So take a look at this equation and jot it down. I'm going to put my balance beam bar right here under the equal sign. And now, before we start annihilating anything on either side, I want you to take a look at this left-hand side. You can combine like terms here. That positive 15 and a minus 9 can combine into simply 6. On this side of the equal sign, you need to distribute so that you can get at the terms inside the parentheses. And when you distribute, you just kind of break out and get rid of the parentheses. All right, now we get to this stage. Now decide, since you have variables on both sides, which term do you want to annihilate? Me, I like going after the small one, so I am going to lob the opposite of this 2x, which is a negative 2x, at both sides of the equation. This side goes to 0. X's, so that's just 0. And now I'm left with 4 on the right-hand side. These two like terms combine to be a 1x. Woohoo! You're almost there. To solve for x, now we simply have to subtract 6 on each side. That goes to 0, and you get x equals negative 2. Grab your calculator, seriously, and go through and check to make sure your answer makes sense. If you check your answer, you will never make a mistake, because if it doesn't work, you're going to go back and fix it. Negative 6 plus 15 minus 9. Oh, that gives me 0. When you come over here and plug in x, 2 times negative 2 plus 2, that's 2 times 0. That's 0. Look at that. Sweet. Let's look at this guy. Challenging one here. All right. There's nothing to simplify on each side, so you decide I'm going to annihilate a 9y by adding negative 9w to each side. Now watch what happens. That goes to 0w and you're left with 3. Let's come over here to the right-hand side. That goes to 0w and you're left with 7. Wait a minute. What just happened here? Your variables totally dropped out and you're left with this statement, 3 equals 7. What? No, it's not. This is not true. This is a false statement. When this happens and you end up with your variables completely wiping out on both sides of the equation and you're left with something that's false, there are no solutions to this equation. None at all. No matter what you try to substitute in for that variable, nothing works. This actually was a lie from the start. These two were not equal to each other to begin with. And we call that a contradiction when that happens. So you might see one like this on your assignment. All right, let's skip that one. I think we'll jump right to this word problem. So take a look at this. All right, Jamie spends the same amount of money each morning. Okay, that sounds a little kind of like OCD, but okay, whatever. On Sunday, he bought a newspaper for $1.25. Okay, so I'm going to write Sunday here. So he spends $1.25 on this newspaper, plus he bought 2 donuts. Now, I don't know how much these donuts cost, but I know he bought 2 of them. So I'm going to write 2 times D because I'm going to let D stand for donuts. Now we get to Monday. On Monday, he bought a newspaper, and the Monday newspaper is cheaper. You know, the Sunday one has all the ads and all that stuff in there. 50 cents, plus he bought 5 donuts. Seems to me Jamie's kind of a pig. Here we go, 5 donuts. Now, it said that every day he spends the same amount of money. So I know that whatever he spent on Sunday has to equal whatever he spent on Monday. Tuesday, I'm going to throw that over here. On Tuesday, he spent the same amount of money again, and he only bought donuts. But we don't know how many donuts he bought. Figure it out. You actually have enough information to do this because this is an equation. So let's decide which variable you want to annihilate. Me, I like to pick on the little one because I hate negative numbers. I'm going to lob a negative 2D at each side of the equation. That goes to 0. All I'm left with is $1.25. On this side, I still have 50 cents, but this becomes 3 D's. Now, isolate the D variable so you can figure this out. So subtract the 50 cents, subtract the 50 cents. That goes away. You're left with 75 cents on this side equals 3D. And when you divide, if you're thinking about money, you're going to find out that 1 donut costs 25 cents. Now, we're not done because that's not what it asked. It said, how many did he buy on Tuesday? I don't know. I just know they cost $0.25. Go back up here to your original thing. It said he spends the same amount of money each morning. So on Sunday, he spent $1.25 plus 2 donuts. How much would 2 donuts be? 50 cents. That's $1.75. Just to double check, on Monday, he spent 50 cents plus 5 donuts. How much would 5 donuts be if they're $0.25 apiece? $1.25, $1.75. So he spends $1.75 each day, and he spent it all on donuts Tuesday. Apparently, he's got a stressful week ahead of him. So what you need to do is divide by 25 cents a piece. See what you come up with. And I think you should get 7 donuts. I hope that he's buying for like the rest of the people at his work rather than eating them all himself. Otherwise, dude, you better go to the gym. All right, this is the kind of stuff you're working on today. Awesome. You're doing some great algebra. Check Schoology for your assignment, okay? Watch for your variables on both sides. Simplify and watch your signs. Good luck, and always, may the force be with you.